You have dropped the term flamingos, and these are these very interesting, nice microscopes. Can you please tell us more about them?
Yeah, so as I said, we like to build custom microscopes for biological applications. And when I was in Dresden at the Max Planck Institute for Molecular Cell Biology and Genetics, at the end of my term there, we had built 8 light sheet microscopes, all different sizes, different purposes, different, just different configurations. And when I then decided to move to the US, it became apparent that there's just no easy way to move these instruments. And it meant a huge break in our science because we simply couldn't continue with the instruments that we had built over the years. Now, one reason is the difficulty of moving an instrument from one country to the other. But also people who had built these instruments had left by now, right? So those were, the typical scenario: a postdoc joins the lab or a PhD student. They start with an empty table, optical table. They built their project. They built a microscope. And then they write their own custom software. And by the time they leave, nobody knows besides them how to use the instrument. And so me as a group leader, I faced the challenge that I had all these excellent instruments, but I knew that if we were to take them apart, it would be very, very difficult to put them together again because these people would not be available anymore. And so when I arrived in Madison, the idea was born to change this and to change it, for us in the lab, to be more sustainable in how we build microscopes, to have the ability to use a common framework, a set of standard parts to build, essentially to replicate these 8 light sheet microscopes in various different ways, using the same parts and the same software, so that we could again build microscopes around samples or for different applications, but 95% is always the same in these instruments. And it's just that 5% change that you need to make to perfect that instrument for a given application. And this is not something that you just do quickly. It's something that takes time, and it did take about 3 years or so. And I was fortunate that in the US, especially at the Morgridge Institute for Research, I was able to recruit engineers. And so I had a software engineer who still works for our lab, Joe, and Todd was a prototype engineer, mechanical engineer, and Rory Power, a postdoc in the lab who did the optics. And this team and others, they were involved in designing an instrument that we would want to use for the coming years, in the next 20 years or whatever. And that would be built from these building blocks. And it was successful. It works. And this is the one and only light sheet microscope that we now use in the lab. So we have a total of 15 or so flamingos built by now. Several of these are still in the US. Some are here. And it allows us to very quickly build microscopes and adapt them and change them. So if a postdoc came and said, oh, I have this cool idea how I would want to change something in light sheet, that person could start with a running microscope and we could just remove some part and modify it. They don't have to start from scratch. It also turned out that these microscopes have a very small footprint, so they were actually portable. Now, this wasn't our original intention, as I described. It was more about being more sustainable in our development. But what it allows us now to do is to move these instruments within the lab, which already may sound trivial, but it's actually quite beneficial if you can put a microscope into your fish room or under the hood or in a dark room or in a seminar room, or you can take it to a lecture and you can use it for teaching. The other benefit was then that we could suddenly use these instruments for collaborations in a much more efficient way. Because again, as I described earlier, when somebody develops a fancy microscope, there's only that one, and it's usually tied to a table into a room and can never ever leave that room. So if you wanted to use that fancy microscope, you would have to travel to that lab, bring your samples, which may be living organisms, living cells, and who knows what happens to them if they are jet lagged as you're going to a different country. Or they simply may not survive the trip. And so it's a lot easier shipping a microscope than shipping a living biological sample. And so the second benefit of the Flamingo was then that we can actively use these instruments to share them with other collaborators, or essentially the entire world if we wanted to, and make them accessible to all scientists. No matter if they have the funds to buy such an instrument, they could just borrow it. And that just opens up a lot of new possibilities for open science and open access.
In terms of pricing, let's put that in perspective. For example, confocal or even the super resolution microscopes, they can go up to 1.5-2 million euros per instrument.
Yeah.
And how is the price? Like, what is the price range of such a microscope, for example?
I mean, it's always hard to compare because, of course, you know, the commercial system, you're also paying for the labor. So if I give you a price for the Flamingo, that would be without labor and the hard work of many scientists in my lab. And but if you just look at the bare price of the components, it's typically between 50,000 euros and 100,000 euros. So of course, it offers the possibility also in terms of funding that, you know, a funding agency like the DFG decides not to give 1 million or 2 million euros to a single lab from which they could buy one of these commercial instruments, but give it to the research community in a way that they may give it to a lab like mine that can build several such instruments from such a generous fund and then distribute these in Germany.